So friends, in our today's session, we are going to talk about bacterial growth curve. So what is a bacterial growth curve? So we have to understand two things associated with it. For example, closed system, and second is the graphical presentation. Now, both of things are associated with how a bacteria or bacterial population multiplies when the conditions provided are limited. For example, limited nutrition source. Second, fixed time interval. So under these circumstances, the bacteria represents its growth in this pattern, which can be presented in a graphical form. And we come to know that the bacteria grows in different phases. Phase 1, phase 2, phase 3, and phase 4. In the beginning, the bacteria has a limited growth pattern, which clearly displays that there is a constant type of parameter, like the number is not increasing, neither it is decreasing. So, first part is called as the lag phase. We are calling it as the lag phase because it lags growth. The bacteria is there, but it lacks growth, means it is not able to multiply. So we don't see any bacterial population to increase in the number. Okay. Then the second part is called as the log phase. Log phase. It is also called as the exponential phase. Now, in this exponential phase, what happens is we already know that a bacteria or a bacterium undergoes binary fission, which means that a single bacteria is able to produce two bacteria. When it is single, it is commonly called as the bacterium, and under the multiple population, whether it is 2, 4, or 100, it is commonly called as bacteria. So bacteria is basically the plural version of bacterium. So we can say that uh, this particular phase is seen under the condition of lag, whereas when the population starts to increase in number, it is called as the log phase. Now, similarly, after the two bacteria have generated and if they undergo the binary fusion, obviously they are going to be two more population, which means it was 2 to the power 1 and now it is 2 to the power 2. So 2 to the power 2 is equal to 4. So 1, 2, 3, and 4. So we have 4 bacterial population, and because uh, 2 is the initial number and 2 is the exponent, hence we commonly call this phase as the exponential, right? It can be anything. It can be 1, it can be 2, it can be 3, it can be 4, and accordingly various number of populations can be determined. So in this case 2 to the power 1 is 2, to the 4, then we have 8, and then we have 60. Okay. Then comes the stationary phase. Stationary phase. So the third part is called as the stationary phase, where you can see that just like the lag phase, the stationary phase also represents a limited population. The bacterial growth is there, but it is not exponentially rising. So what happens is like in the first condition, if we see with respect to the uh, nutrition, the uh, in the initial phase during the lag phase, the concentration of the nutrition in the given media is at its peak. But as the concentration of nutrition, uh, minute, should use nutrition from here, and we should use time, yeah, time. And here we mention nutrition concentration. So the concentration of the nutrition is peak during the lag phase, and as the lag phase ends and the log phase initiates, at that time the concentration of the nutrition slowly starts to deplete. Then from log phase, we have the exponential phase where the concentration of nutrition is almost depleted, and during the decline phase, the concentration of nutrition is absolutely depleted, right? So that is one of the reasons why, because if there is no nutrition, there is no bacterial growth. Okay, fresh bacterium will not be able to grow in that particular medium, and this because of and that is because of two factors. Uh, the very first one is because the nutrition is directly proportional to the bacterial growth. Hence, we can say that as the nutrition decreases, the bacterial growth also depletes. Okay? And there is a particular time where the concentration of nutrition is equilibrium in with that of the bacterial growth. So that is why one can easily see, or one can easily understand that this type of equilibrium is commonly seen in case of phase number 3, which is the exponential, which is the stationary phase. Okay. Now comes the decline phase, which is the fourth stage, decline phase. So what is happening in decline phase? So during the decline phase, two things happen. First is obviously there is the nutrition in the media has been depleted, so that hinders the uh, new bacterial new bacterial population, which means that no new bacterial growth is seen. Okay, and secondly, what happens when the nutrition is utilized? Is utilized. So whenever nutrition is utilized, it is broken down by the uh, catabolic and anabolic processes, which leads to the generation of two type of products, namely products which can be utilized, products for growth enhancement, and product for growth restrictions. Now, the products which can be used for growth enhancement, they are commonly called as the primary metabolites, whereas the product which are used for the growth restriction or growth inhibitors, most of them they are called as the secondary metabolites. Most of them are basically toxins. So the bacterial population is in fact the bacterial growth is basically hampered because of two things. First of all, the nutrition has been depleted. There is poor nutrition present in the medium. Secondly, after digestion of the metabolites or after the digestion of the nutrition, the type of secondary metabolites or the toxins which has accumulated in the system acts on the bacterium which are present in the system. That's why we can see that immediately after the the third phase or the stationary phase comes the decline phase. So what is happening over here that the new bacterial cells are not growing. So new bacterial cells is basically hampered because because the toxins which has been produced, the toxins or the secondary metabolites which has been produced in the system acts on the presently available bacteria and declines their number. Okay. So this is the reason why we can observe the different types of phases in the bacterial growth curve. So there is a mechanics behind it, and that mechanics involves the identification of several factors which are used in biotechnological application, and it is also used for the medical microbiology application, which can assist the researchers or the companies to formulate various type of products according. So I hope so that in this particular video you have got a new outlook towards the bacterial growth curve and some new concepts in terms of mechanics or the core concept has been really revealed to you. I hope that you would like this video. Please hit the like button and don't forget to subscribe my channel and share it among your friends, colleagues and peers. Thank you.